Reactivity is basically a natural material. Is available in the mines, and once it is available in mines, we have to take out the material and burn at particular temperature. Then it start reacting. So for that, there is a specification is there 160. It is recently introduced the specification. Earlier, the specification was not there. 2015 16354. This also you note down, and this is for cement, mortar, and concrete. Metakaolin. Kaolin is the material. See, this is the material which is available in the mines. So then you can fire it or heat at the temperature around 850 or so. Or whatever is silica is there, you become a amorphous silica, and then the material is look like this. Now here one has to be very careful about the temperature. If you go beyond that temperature, the silica become a crystalline. If the crystalline silica is a non-reactive, it is not helpful for your concrete. So pozzolanic material, it has got capacity more. Calcine refined kaolin clay. This is called basically kaolinitic clay. Fired at 650 to 850, depend upon the quality of the materials. So you fire at this level at temperature, and then again you grind into ball mill at minimum fineness about 9,000. Now cement is 3,300. Microsilica is 15,000. Now it is only 9,000, 9 to 10,000. Now you can imagine coarser cement, then you have got finer material like this, then you have fly ash, and you can use this. So you have three variety of material you can combine such a way that you get maximum packing density. So this is L2O is there, silica is there, also some amount of Fe2O is also there in this. So 94% silica and aluminates. This is a requirement as per IS code, whatever I earlier we are given. And ratio is 1.15 minimum. This is 3, and Al2O3 also minimum is 40%, and alloy 2%. So when you are using such material, you have to analyze it and see first whether they are meeting our requirement. Then only we can go for use in concrete. Specific surface BET 9,000. Oversize material 1.5. Retention on 45 micron. For fly ash, this is 34%. Now here it is 1.5%. And that densified one, it is around 10%. Now here see the compressive strength 7 days. It is 100% with the control sample. Replacement level 10%. Even if you replace 10% with OPC, you should achieve 100% strength. That is the requirement minimum. So such a reactive material is there. In fly ash, we are talking about 80%. And microcilia, we are talking about 85%. At 10%. Here it is 100%. Because very, very reactive material. If it is fired at or temperature properly fired at the temperature 650 to 850 to get a reactive or amorphous silica. Not crystalline silica, because most of the people, they were not able to manage this, because in market lot of materials are available. So one has to taste this, and then only we can advise for the site to go for it. The temperature variations are getting a issue in the processing. 2 slides about your rice husk ash. You know this. This is also very good material as a pozzolanic action. Rice husk ash. You know this rice husk. Once you get the rice, those covers are available that can be burned at a particular temperature. You will get silica like this. But if you are not burned properly, you may get like this. This is having a lot of carbon. So under controlled temperature, about 800 or so, if you burn this also get a very good reactive silica in it. See here, around 800, below 800. Rice husk ash. The agriculture byproduct burning husk under controlled temperature about 800. The process around 25% ash and 85 to 90% amorphous silica. This is important for concrete. And 5% alumina is highly reactive material. And rice husk has got very porous texture. If you see in microscope, it is a very porous texture. So if without grinding also we can use this material, and gives excellent compressive strength of materials. Only thing is, condition is it has to be controlled at particular temperature, and that brownish color turned into the white color, as I showed you earlier. It comes like this, and you are able to gauge like this. It is a highly reactive material. You can effectively use in concrete. See, this is what texture is. See, this is the rice husk photo. This is a normal rice husk available in the market. It has got still it has got carbon in this. That's why it is in gray in color. But real properly temperature controlled temperature material convert into the white color. See, this is the SEM of that rice. You can say a lot of porosity is there in this. Now inside also the cement grains goes there and it is reacting. So it is highly reactive material, but it is not yet properly marketed in India, because we are one of the largest rice producer in India. But we are not basically use this potential till now. Some portion in Bengal or some Tamil Nadu people are working it, but nobody has worked it very carefully or systematically way, because the volume transportation is the issue. So one has to design a system which can go to the farmer level and burn there and get the silica, because the silica will come around 25% of that. If you 1 kg of rice husk, you will get around only 250 grams of this material, but it is a very reactive material. So this is one of the very good business for new civil engineers to see the potential of this material available in India. I think with this we can conclude today's lecture. Anything is there question, whatever we have covered now for last 2 lectures, supplementary cementitious material, fly ash, GGBS, microsilica, rice husk ash and metakaolin. So you can spend 5-10 minutes for that, because next lecture will be on chemical admixture. Now we are going to mineral admixture. Now next lecture we are going to cover chemical admixtures. Yes. See, whatever I discuss may not be some of the not in the presentation, but whatever you discuss, you must note down those issues by properties of material, then mixing time, then prevention, how to prevent the cracks, what care you have to take, modification of admixture. These are the points we have to remember always when you are talking, when you are handling this concrete with these materials.